Question number 81. NH3 plus BF3 gives NH3 an covalent bond with BF3. And here BF3 is covalently bonded with NH3. Here nitrogen has 3 hydrogen atoms attached and boron has 3 fluorine attached, and nitrogen and boron are attached to each other also. Boron will have a negative charge, nitrogen will have a positive charge. So student, we know that the hybridization of boron in BF3 is sp2. The hybridization of nitrogen in NH3 is sp3. The hybridization of boron in NH3BF3 is sp3, and the hybridization of nitrogen in NH3BF3 is sp3. Now we'll be able to identify the correct option. Change in hybridization of nitrogen takes place only. No student, it is very clear that the hybridization of nitrogen has not changed. Moving to next. Change in hybridization of boron takes place only. Student, this is a correct statement because there is a change in hybridization of boron only. Going to next. Change in hybridization of both boron and nitrogen takes place. No, again in incorrect option. No change in hybridization of boron and nitrogen takes place. So students, this is again an incorrect statement. That means the correct statement is option number 2, or we can say that the correct answer is option number 2. Moving to next question, which is question number 82. Let's read it. Formal charge of central oxygen atom is. Student, here we have to understand the formula to calculate formal charge, which is equals to number of valence electrons minus number of non-bonded electrons minus half into number of bonded electrons. So we have to identify the formal charge on the central oxygen. So valence electrons will be 6 minus number of non-bonded electrons, which is equals to 2, minus half of bonded electrons, which is equals to 6. That means formal charge is equals to plus 1. So the correct answer is option number 3. Moving to next question, students, which is question number 83. Let's read it. If internuclear axis is x-axis, then which of the following overlap results in sigma bond formation? Student, if the internuclear axis is the x-axis, then we have to identify that which will result into sigma bond formation. 2py and 2s, no. Py, 2py and 2py, this will result into a pi bond formation. 2py and 2px, no bond will be formed. And the last is 2px and 2px. Student, yes, this will result into a sigma bond formation. Sigma bond which is formed due to the axial overlap of atomic orbitals. That means the correct answer is option number 4. Moving to next question, students, which is question number 84. Let's read it. Number of sigma and pi bonds in the given compound, which is naphthalene, are. Student, first of all, I'm drawing the structure clearly to identify a number of atoms attached and all the hydrogen atoms also. So we can easily calculate number of sigma bonds. So students, it is very clear that the number of sigma bonds in the given compound are 19 and the number of pi bonds are 5. I have already marked all the sigma bonds and all the pi bonds. It is very clear that from here also we can identify number of pi bonds, which is 5. That means the correct answer is option number 4. Moving to next question, students, which is question number 85. Let's read the question. Diamagnetic species among the following is. Student, for this question we need to understand the species which have no unpaired electrons are diamagnetic. O2 has 2 unpaired electrons, therefore it is paramagnetic. O2 plus has 1 unpaired electron, therefore it is also paramagnetic. O2 minus has one unpaired electron. Again, this is paramagnetic. O2 2 minus has no unpaired electrons. As a result, O2 2 minus is diamagnetic. I'm writing the electronic configuration of O2 2 minus. The electrons are 18. So sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then we have sigma 2pz2. Then we have pi 2px2, pi 2py2, pi star 2px2 and pi star 2py2. That means there is no unpaired electron in O2 2 minus. As a result, O2 2 minus is diamagnetic. So the correct answer is option number 4. Moving to next question.